In this video, I'm going to use the multiplication rules to do some more examples, and we're going to start with one having to do with the deck of cards. So in this example, 3 cards are drawn from a deck. After each card is drawn, its denomination and suit are noted, and it is replaced before the next card is drawn. Find the probability of getting. So we'll start with 3 kings. So we've got 3 cards being drawn. The fact that we're replacing each card before drawing the next one tells us that these events are independent of one another. And that means we don't have to be careful doing the second and third probability when we're multiplying, because they're completely independent with each other. So to find the probability of 3 kings, we're just going to find the probability of picking a king first times the probability of the second card being a king times the probability of the third card being a king. All of these are going to be out of 52 because there are 52 cards in the deck, and each time we replace the card. So this first pick, there are 4 kings in the deck, so there's a 4 out of 52 chance that I pick a king. I put that card back, shuffle it, and there's still 4 out of 52 chance of getting a king. Put that card back, shuffle it, and then there's a 4 out of 52 chance that the last card is king. And so now all I have to do is multiply these together. This seems simple, but actually this is the step where you do have to be careful depending on what calculator you have. If you have a TI 3430 and you put in 4 out of 52 times itself, I'll do this one time just so you can see. If you enter it in using the fraction button, times 4 out of 52 times fraction 4 out of 52, and then hit enter, you'll get an answer. Your calculator will do it, but it's not going to be a fraction. So it depends on what type of answer you're looking for. So if you're looking for a decimal answer, I'm just going to put approximately down here. Let's say it asks for 5 decimal places. So you could write 0.00046. So if it asks for a decimal, then you're all set. If you're trying to find a fraction, an answer as a fraction, this calculator won't actually change this to a fraction. It does have a button to convert decimals to fractions if you hit second and then the N over D button. Unfortunately, it will produce an error here because the decimal is too small. If we had a bigger decimal like 0.25 and then we press that button, it would change it to a fraction for us, and then we could go ahead and use the simplify key and all would be well. But it doesn't work here because these fractions are just too small. And so one workaround is we could take the fractions and we could reduce them, and your calculator can help you with that. So by hand, you could just divide both of these by 4 and get 1/13 times 1/13 times 1/13. If you don't want to do it by hand, you can put 4 over 52 in the calculator, come out of the fraction, and then hit simplify until you see a factor of 1, just to make sure that you've simplified it all away. And so you can see it simplifies it to 1 out of 13. Now, if you put 1/13 times 1/13 times 1/13 in the calculator, it's still going to give you this decimal. So if you want the fraction, you have to multiply separately the numerator and denominator. So 1 times 1 times 1 is 1, and then 13 times 13 times 13 is 2,197. So once you reduce and your denominator is 1, you know that in the end this is the reduced fraction. It's in lowest terms. So this is how you could get the decimal answer, approximation, and then also the fraction. Let's look at the second example. So the probability of getting a king, and then a queen, and then a jack. Okay. And so in this case, we're going to look at the king first. So there are 4 out of 52 kings in the deck. We replace that card, shuffle it. There are 4 out of 52 queens, and there are 4 out of 52 jacks. So this is actually the same exact problem that we just did. So this is also 1 over 2,197, or approximately 0.0046. I do want to show you real quick, if you have a graphing calculator, the nice thing about a graphing calculator is its memory is large enough that it can store all of this and give you the fraction. So you can just use parentheses around each fraction and the division sign to enter 4 out of 52 times 4 out of 52 4 out of 52. I could put a time sign in between those, but I don't have to. Hit enter. Now this is important to notice. So this is scientific notation. So when you see in the graphing calculator 4.551661356 e negative 4, that e negative 4 means times 10 to the negative fourth power. So we need to take this decimal and go 1, 2, 3, 4 spots to the left and put placeholder zeros. And what do you know? It's the exact same decimal as above. And then if you hit math, enter, it will give you the fraction, which is 1 over 2,197. So if you have a graphing calculator, then that can be a huge help. So let's look at example 5, which will look at the same exact problems, but without replacement. So we're going to find the probability of picking 3 kings again, only in this example we're going to assume that when we pick a card it is not replaced, it's set aside, and then the second card is picked or the third card's picked. So this means the events are dependent, and that means that when I multiply the probabilities, so the probability of king times the probability of a king times the probability of a king, I need to take into account what I have already done and how that affects the next pick. So for the first choice, nothing has happened yet. I still have a deck of 52 cards. So the probability of picking a king right now is 4 out of 52. So 4 out of 52. Then when I pick my second card, I am going to assume here, so I'm going to erase that, what I just drew. I'm going to assume that I picked a king the first time. I'm going to cross that off. So now how many cards do I have? I only have 51. How many kings do I have? I have 1, 2, 3 kings. So there's a 3 out of 51 chance that I pick a king the second time. Then for my third pick, I'm going to assume I pick a king the second time, so I cross that off, and now I only have 2 kings left and 50 cards in the deck. And so see how my denominator goes down each time because I'm picking a card and not putting it back. My numerator is decreasing because I keep choosing to pick a king, and so the kings are decreasing each time. And so I'm going to multiply these together, and just like the last problem, so depending on your calculator, if you have a graphing calculator, you can throw parentheses around these and multiply them and be fine. If you have a TI 34 or 30, I would recommend reducing these first. And so the way that you're going to do that, you could either do it by hand. So 4 out of 52, you could reduce this by dividing both by 4 and getting 1/13. If that's difficult, you could use the N over D button and put in 4 out of 52, put your right arrow, and then hit the simplify button. And keep hitting the simplify button until you see a factor of 1 here, and you can see it reduces it to 1/13. And then reduce 3 out of 51. And so if you reduce 3 out of 51, let's do it the same way. So 3 out of 51, and then we're going to hit the simplify button, and we get 1 out of 17. And remember, if you have a graphing calculator, you don't have to be reducing here. You could just multiply these all together, times, and then 2 out of 50, we could divide these both by 2. I'm just going to do this one by hand, and we get 1 out of 25. And so then I can multiply the numerators. 1 times 1 times 1 is 1, and then 13 times 17 times 25 is the denominator, and I get 5,525. Okay, and then if I want the decimal, I can just do 1 divided by 5,525, and then that's the decimal answer, and you can round to, whatever you're asked to round to, depending on what the problem asks. In this problem, I'm just going to leave it like that. And so for this next one, I'm just going to write down probability of king times probability of queen times the probability of jack. And then I'm going to erase the marks that I had from the previous problem. Okay, so I have 52 cards to start with, and there are 4 kings. So I'm going to say 4 out of 52 is my chance of getting a king. Now, if I pick a king, I'm going to cross that off. Now I have only 51 cards in the deck. How many queens do I have? Well, 1, 2, 3, 4. There are 4 queens. So notice in this example, my numerator doesn't decrease at all because I'm asking for a different card. So this picking a king the first time didn't affect my numerator of picking a queen. And then I'm going to cross out a queen, representing that second pick of a queen. And I look at my deck and I say, okay, well, I have 50 cards left now. How many jacks? 1, 2, 3, 4. There are 4 jacks. So 4 out of 52 times 4 out of 51 times 4 out of 50. And so I'm going to reduce those each individually. So I'm going to divide 4 out of 52. We can divide both by 4 and we get 1/13 times 4 out of 51 is not reducible. So if you want to use your calculator to do that, I'll just show you what that looks like. When you hit simplify, it just shows you a factor of 1 immediately and you get the same fraction. So that just shows you it's not reducible. And then we'll do the third fraction. So 4 out of 50, we can divide both of those by 2 and we get 2 out of 25. And so I'm going to multiply my numerator. So 1 times 4 times 2, I get 8. And then my denominator, 13 times 51 times 25. And I get a denominator of 16,575. And like before, if you want a decimal, you can just divide 8 by 16,575. Okay, and then like I said, with the graphing calculator, you can just make sure you put parentheses around each one of those fractions. I'll show you real quick. So 4 out of 52 times 4 out of 51 times 4 out of 50. Okay, we get scientific notation. So this means take that decimal and move it 4 spots to the left, putting in placeholder zeros if you want a decimal answer, or hit the math enter button. And you know what? That doesn't actually give me a fraction there. So it looks like in this case, the graphing calculator, I'm glad I did that one. We wouldn't get a fraction there either. Let's see, just for fun, I'm going to do my reduced version. So 1 out of 13 times 4 out of 51 times 2 out of 25. Let's see what happens. So I get the same decimal. Yep, it doesn't do it that way either. So I guess even with the graphing calculator, you're not, there's a chance you're going to have to do some of this by hand. So it's a good thing we went through that. Okay, so let's look at one more example. So in example 6, we have an appliance store that gets a shipment of 45 freezers and 3 of them are defective. If 2 are chosen at random, find the probability that both are defective. So because we have successive events, that means one thing is being chosen and then another, that means we need to use our multiplication rules. And in this case, since the first freezer is not replaced after it's tested, these are dependent events. So I'm going to find the probability of picking of the first freezer being defective times the probability of the second freezer being defective, assuming that, we didn't replace this first one. So let's look at the first freezer. So if we have 45 freezers and 3 of them are defective, there's a 3 out of 45 chance that that first freezer is going to be defective. Okay, now if this defective freezer is taken out, you're going to have to imagine for a minute that you have 45 freezers. And if you need to, draw a picture. I mean, you could literally draw 45 different rectangles, okay, to represent freezers and cross off one to represent, okay, we picked this first freezer. Now how many freezers do I have? Well, I don't have 45. I now have 44. And so this second fraction is going to be out of 44. And if I did have 3 defective ones, now I only have 2 because this first was a defective freezer that I picked. And so the numerator is going to decrease as well. So I've got 3 out of 45 times 2 out of 44. And so just like before, it doesn't hurt to try to reduce these first. So you could reduce these either by hand. You could divide these both by 3, you could put it in your calculator. If we do this, we get 1 out of 15. And then we could divide both of these by 2, and we get 1 out of 22. And then I can just multiply 1 times 1 is 1, and then 15 times 22, we get 330 on the bottom. And so there's a 1 out of 330 chance that both freezers that are chosen are going to be defective. And then if you want a decimal, you just do 1 divided by 330, and you can get the decimal for that.